of unity, prove that n exists as natural number, then 1 plus omega n plus omega 2n is equal to 3. And if n is a multiple of 3 or 0, if n, my English is very broken here. All right, so then 1 plus omega to the power of n plus omega to the power of 2n is equal to 3 if n is a multiple of 3, okay? Or it's going to equal to 0 if n is not a multiple of 3, okay? Let's state out what we know first. So because omega is cube root of unity, right? Cube root of unity. So what we can write is that omega cubed is equal to 1, right? Because it's a cube root of unity, so omega cubed is 1. And we know that omega cubed minus 1 is equal to 0 by rearranging this. And then straight away, we have your cubic expansions, omega squared plus omega plus 1. This equals to 0. And your omega is your smallest positive angle, okay? Is your smallest positive angle that gives you. So your omega does not equal to 1. Therefore, 1 plus omega squared equals to 0, okay? This is an important fact that you need to derive out from your cube roots of unity or your roots of unity in general, okay? Now, let's consider the first fact. If n is a multiple of 3, it's telling me that 1 plus omega to the power of n plus omega to the power of 2n is equal to 3. So now let's consider the first fact. Let n equals to 3m, where m again is existing as a constant, okay? N is just some natural number. All right, so now I know that n equals to 3m. Let's start applying to my formula of 1 plus omega n plus omega 2n, okay? I'll get 1 plus omega 3m plus omega 2 times 3, right? Essentially, by using our indices laws, what I can get is omega cubed to the power of m plus omega cubed again, but now to the power of 2m, okay? I'm just switching the places of the powers, which means I get 1 plus 1 to the power of m plus 1 to the power of 2m. And we know 1 to the power of anything is still 1, right? So essentially, I'm just getting 1 plus 1 plus 1, which is equal to 3. So that's n equals to 3m, and being a multiple of 3 proved, okay? And then do not stop there. We got a second fact, or 0 if n is not a multiple of 3. If n is not a multiple of 3, then what we can let n be is let n equals to 3m plus 1 and n equals to 3m plus 2. These are the two possible combinations, right? So let's go with the first fact first. Let n equals to 3m plus 1. What we will get is 1 plus omega 3m plus 1 plus omega 3m plus 1 times 2 on the outside, okay? So this is when n equals to 3m plus 1. And I'll get 1 plus omega 3 to the power of m, right? By indices laws, I'm going to drop that plus 1 down, which is just omega. Plus, again, omega, I'll get 6m, so I'll do this a bit slow, 6m plus 3. So get 1 plus 1 times omega plus omega, I'll get 3 to the power of 2m times my omega squared over here. I'm dropping the power, okay? I'm dropping the power into a separate omega squared. So I get 1 plus omega and essentially plus omega squared, okay? This, as we already clarified on the top, 1 plus omega squared equals 0. So that's my 0, okay? Now I'm going to prove my second condition. So I'll prove it in red to differentiate. N equals to 3m plus 2. Okay, so now say let n equals to 3m plus 2. What we will get is 1 plus omega 3m plus 2 plus omega 2 times 3m plus 2. Right. Again, I'll get my 1 plus omega 3 to the power of m times omega squared plus omega to the power of 3 and then m plus 1. Okay, I'm factorizing and then times by m. And then times by omega alone. If you want to know how I do this, I'll just do this on a separate line. Omega squared 3m plus 2. What I get is omega 6m plus 4. So I factorize the 3 out. So 3m plus 2m plus 1. 2m plus 1. Should keep here, 2m plus 1. And then times it by omega alone, right? My single one over here. So what I'm left with is 1 plus 1 times omega squared plus 1 again times omega. So essentially what I get is 1 plus omega squared again and equals to 0.